Hello student, this is Shivam Misra. Again going to explain some of the questions of ITF once again. ITF is a very important chapter. It is a vast syllabus for formula. So you need to memorize all the formulas and then try to practice question more and more so that the concept remains in your mind. Sine 2 tan inverse 3 by 5 minus sine inverse 7 by 25 equals to 304 upon 425. It was given to you sine 2 tan inverse 3 by 5 minus sine inverse 7 by 25 equals to 304 upon 425 we need to show. So what we will do, we will just start with the 2 tan inverse 3 by 5. So 2 tan inverse 3 by 5 leads to sine inverse 2 dot means I am applying 2 tan inverse x formula that sine inverse 2x upon 1 plus x square. So 2 into 3 by 5 upon 1 plus 3 by 5 whole square. So this gives sine inverse 15 by 15 by 15 by 17. This leads to this equation. On solving you will get sine inverse 15 by 17. So next we will apply on sine inverse 7 by 25. We have this one term, we have this sine inverse 15 by 17 minus sine inverse 7 by 25, applying sine inverse x minus sine inverse y. We have the formula sine inverse 15 by 17 under root 1 minus 7 by 25 whole square minus 7 by 25 under root 1 minus 15 by 17 whole square. And on solving this, you will find the result sine inverse 304 upon 425. So this shows our theorem, our proofs. So we have a question. Once again, we will see sine in. We have sine 2 tan inverse 3 by 5 minus sine inverse 1 by 25 equals to 304 upon 425. This is a big term. So we need to go with the left hand side only. 2 tan inverse, we will start with the 2 tan inverse 3 by 5. We will just try to convert it in the form of sine theta. 2 tan inverse 3 by 5 can be converted in the form of sine theta, such as we have formula 2 tan inverse x equals to sine inverse 2x upon 1 plus x square. The same formula we will apply. So we will get, on solving this, we will get a result sine inverse 15 by 17. So this will change to sine inverse 15 by 17 minus sine inverse 7 by 25. And on solving sine inverse x minus sine inverse y formula, you will get a application sine inverse x minus under root 1 minus y square minus y under root 1 minus x square in a bracket. And on solving this, you will get sine inverse 304 upon 425. So this is a way to solve the questions. You can solve all the steps. We will show some more question. We need to check it out. Suppose we have a question. One more question. Cos inverse 63 upon 65 plus 2 tan inverse 1 by 5 equals to sine inverse 3 by 5. Once again, I will remind you, I am discussing all the questions of board. You need to solve more and more questions to get the clear idea and get the collection of all the questions, whatever I am telling to you. If you are finding any other questions typical, then you can forward it to your group or to me by any method. Cos inverse 63 by 65 plus 2 tan inverse 1 by 5 equals to sine inverse 3 by 5. Suppose this question, then this question can be simplified. First of all, we will try to simplify this term 2 tan inverse 1 by 5. So 2 tan inverse 1 by 5, 2 tan inverse 1 by 5 can be written as cos inverse 1 minus 1 by 5 whole square means 1 minus tan square theta upon 1 plus 1 by 5 whole square. So this is the logic. So we will get cos inverse 63 by 65 plus 2 tan inverse 1 by 5, and on simplification this gives cos inverse 63 by 65 plus this term changes to cos inverse 12 by 13. On simplifying, cos inverse will get 63 by 65 dot 12 by 13 minus under root 1 minus 63 by 65 whole square under root 1 minus 12 by 13 whole square. On simplifying, you will get a result cos inverse 756 minus 80 upon 845, and on simplifying you will get cos inverse 4 by 5. This can be written in form sin theta, so sin into apply sin inverse 3 by 5. Once again we will see, we have a question cos inverse 63 by 65 plus 2 tan inverse 1 by 5 equals to sin inverse 3 by 5. So what we'll do, we will just 2 tan inverse 1 by 5, we'll try to convert this step term in the form of cos theta. It will result to cos inverse 1 minus tan square theta upon 1 plus tan square theta. Cos inverse 1 minus x square upon 1 plus x square. So cos this, on solving this you will get cos inverse 63 by 65. So the first term, and 2 tan inverse 1 by 5, on this place you will write cos inverse 63 by 65 plus cos inverse 12 by 13. Means on solving this term you will get 12 by 13. So cos inverse x plus cos inverse y will leads to cos inverse xy minus under root 1 minus x square under root 1 minus y square. On solving this you will get cos inverse 4 by 5, and changing this term to the form sin theta you will get sin inverse 3 by 5. So this was the required result which we need to prove. So some more questions and more topics you will see in the next lecture. Till that, you can solve all the questions and attempt more and more questions to get the command of yours on this chapter. Till that, thank you.